So with example 8, the polynomial p of x equals x plus 1, x minus 2, x plus 4 has 3 zeros at negative 1, 2, and negative 4, because those are all the factors, right? And the factors you could set equal to 0 and you get the x-intercepts, or the roots, or the zeros. So negative 1, 2, and 4, which means if they're x-intercepts, what coordinate are they? When you hear x-intercept, you should immediately think y equals 0. Yes, that should be like right there. So proud of you.
Thank you.
Yeah. You know, I feel like you should stand up here and like thank you, Mom and Dad, for supporting us. Okay. So when it says x-intercept, you should immediately think y equals 0. And when it says y-intercept, you should immediately think x equals 0. Yes, that should be like, woo, right there. Seriously, because you know how many times questions on a test you don't get right because you literally just don't make it a coordinate. That's it. That's all. So when they say zeros, x-intercepts are roots, we know that we have coordinates at negative 1, 0, 2, 0, negative 4, 0. Use transformations to determine the zeros of each of the following. So we're going to affect coordinates. And we affect coordinates, we use mapping. You know, today, just right there. Okay, so this is a what? We're going to talk about the transformations first. Yes.
Stretch and reflection.
Yes, and it's a what stretch? Yes, it's a vertical stretch. That's what I did. I don't know. I stopped there. It's a vertical stretch by a factor of 2 about the x-axis because it's with the y's, right? Yes. Boom. We didn't say negative 2 because the negative 2 is actually a reflection in the x-axis. Boom. Okay. So we do what we say. So we said there's a vertical stretch by a factor of 2 and a reflection in the x-axis, which means I'm going to multiply by negative 2, right? Words, mapping, same thing. I don't flip anything. I don't change anything. What my words are, I use those same numbers. So what am I going to multiply by negative 2? My x or my y? My y, because unless it's in this bad boy bracket, it's going to go to my y. So it's going to be x comma negative 2y. Now you're all brilliant beings. What's going to happen to negative 1, 0, 2, 0, and negative 4, 0 when I apply that mapping? They're going to stay the same, which is called what? Invariant. She can't get better today. I didn't think so, and then she just keeps getting better. Okay, so invariant means it can't change, and why can it not change? Why are these not going to change? Yeah.
Because 0 times whatever is 0.
0 times whatever is 0, and these are all on the x-axis, and the x-axis, when you have a vertical stretch or a reflection in the x-axis, is where your invariant points lie. Now, if I throw a vertical translation in there, that goes right out the window, right? Because where they would be, they're now going to move up or down. So they're going to totally move off the x-axis, right? So it's only if they have a vertical stretch and a reflection in the x that the x-axis remains invariant. The moment I throw a vertical translation on there, that's right out the window. Okay? So it says, use transformations to determine the zeros of each of the following. Well, this is going to be negative 1, 0, 2, 0, negative 4, 0. And I could show mapping to show that, right? If they say algebraically determine, we really want to show mapping here. We don't want to just write a point, write these 3 points, because that's not algebraically. Maybe you just went to your calculator and right? So we have to show mapping in that case. For B, we have 1/3 x. It's with the x. It's in front of the x. It will forever and always be a horizontal stretch, and it will forever and always do what? Flip. So the 1/3 will become a 3. So we're going to get a horizontal stretch by a factor of 3 about the y-axis. Now mapping means if it's 3 in the words, it's going to be 3 in the mapping. That does not change, right? They're in a heart. They love each other. Best friends, BFFs. So if it's a horizontal stretch by a factor of 3, I'm going to multiply by x's by 3. And why my x's? Because it's with my x. So I'm going to get 3x. That's not mapping. Come on, let xy becomes 3x comma y. So we're going to plug in. We're going to get negative 1, 0 becomes 3 times negative 1, 0. So that point's going to be negative 3, 0. And then we have 2, 0 is going to become 3 times 2, comma 0, which is 6, 0. And then we have negative 4, 0 becomes 3 times negative 4, comma 0, which is negative 12, 0. Right? So this one says, write the replacement for x or y, and then write the equation of the image of y equals f of x after each transformation. Remember, replacement is x becomes this in the equation, y becomes this in the equation, right? The arrow. And then I want the equation. So go and try. A, B, C, D. I want replacement and equation, and why not mapping? Okay, this one has a horizontal stretch by a factor of 6. So I know if I want to do mapping right away, it matches that. So I'm going to have xy becomes 6xy. Right? Words and mapping are the same. Replacement and equation are the same. So my replacement then would be x becomes what? 1 over 6x. And my equation is y equals f of x. So I'm going to get y equals f of 1/6 x. There's my 3 things. Vertical stretch by a factor of 1/5 about the x-axis. So I'm going to get xy, vertical stretch, so it's going to be multiplied by my y, right? So I get x comma 1/5 y. My replacement, y is going to be 1/5 y, or 5y. Remember, because it's with the y on the other side, so it would actually flip, wouldn't it? Then my equation would be, I would replace it. So I'd go 5y equals f of x, divide by 5, and y equals 1/5 f of x. A reflection in the x-axis. If it's a reflection in the x-axis, it actually affects what? The y. So I'm going to have xy becomes x comma negative y. And then we have a vertical stretch by a factor of 3. So I'm going to get a 3y. Negative 3y. My replacement, y is going to be replaced with 1/3 y. And then I get negative 1/3 y. I get negative 1/3 y equals f of x. So y would actually equal negative 3 f of x. Because I would multiply by negative 3 to get it over. Right? And then a horizontal stretch by a factor of 1/2. So I have xy becomes 1/2 x, because mapping and words are the exact same thing, so I'm going to use the same numbers they have, and 1/4 y. Between mapping and words, if the words have those numbers, the mapping's going to have those numbers, right? Doesn't flip. Replacement always flips. So x becomes 2x, y becomes 4y. So I'm going to get into my equation y equals f of x. I'm going to get 4y equals f of 2x, and then I divide that 4 over, and I actually get y equals 1/4 f of 2x. Right? Because you can ask to do any of the 4 things. Okay. Why don't you do example 10? This one that doesn't seem to have an example number. Yeah. And then example 11. For this page. So this one I would first divide that 3 over because it's in replacement notation form, right? So I get y equals 1/3 f of x. And it says, how does it compare? What kind of stretch is it? Vertical stretch by a factor of 1/5. 1/3, because it stays the same always, about the x-axis, because it's with the y. What happens to the graph? You make these changes. Replace x with 4x. So we get y equals f, toss the x behind the head, and replace it with a 4x. Yeah, let's go. Okay, so we have a 4x, which means we have a horizontal stretch by a factor of what? A factor of a quarter, because it's going to be a reciprocal, about the, which axis? Y. And my mapping, I do what I say. So xy becomes 1/4 xy, right? The numbers that are in words will appear in mapping. They're the same thing over and over and over. Replace y with 1/3 y. So we get 1/3 y equals f of x. How do I move a third over? Multiplying by 3. So I get y equals 3 f of x. So I have a vertical stretch by a factor of 3 about the x-axis. And then we go xy becomes 3x. Ooh, that's on the y. Silly me. x3y. Because whatever number comes up in the words gets repeated in the mapping. Now replace y with 6y and x with 1/3 x. So we're going to get 6y equals f 1/3 x. If I move that 6 over, I divide. So I'm going to get y equals 1/6 f 1/3 x. I always have to go in the order stretch, reflect, translate, right? SRT. So I'm going to do a vertical stretch by a factor of what? What's by a factor of 6? About the x-axis. And a horizontal stretch by a factor of what? 3, because those flips, about the y-axis. And then my mapping uses these numbers. So if in this wording I have 1/6 and 3, my mapping will have 1/6 and 3, right? Mapping word, same thing. So I'm going to get xy becomes 3x, comma 1/6 y. And moving a graph, for example, 11. What do I use if I move a graph? Mapping. So this is affecting my x, correct? So it's a reflection in the y-axis and a vertical stretch by a factor of a half. So, or 1/2. So we're going to get xy becomes -1/2x, comma y. And then I would use my points. So I have -5, 0 becomes -1/2 times -5, comma 0, which is 5/2, which is 2.5 and 0. That's 6. Well, that's disappointing. I just see that when I got close. Oops. Oh, Svenja, that's not the right number. Okay, -6. Well, it's nicer. And it would have been positive, so I'm not sure why I was drawing it there anyways. That would have been just stupid. 3, 0. Which makes sense. It's a reflection on the y-axis, right? If a point's on the left, it's now going to be on the right side of the y-axis. And then I have -4, 2. becomes negative a half times negative 4 and 2. So it becomes 2, 2. Connect them. 0, 5 becomes negative a half times 0, comma 5, which is 0, 5. Why did it stay the same? Because my reflection is on the y-axis if all I have happening is horizontal stretch and a reflection in the y, right? So that's staying. So that's my invariant point, right? And then I have 4, 4. It's going to end up negative because that's reflect. So negative a half times 4, comma 4, negative 2 and 4. That's where I'm using black, it just blends. Now that is actually 5. Oh, the point would have ended up happening anyways, where I put it wrong in the first place. So it's negative 2.5 and 0. And then 6 and negative 4 is negative a half times 6, comma negative 4, which becomes negative 3, negative 4. Something is shady. What's shady? Did I connect this wrong?
No,
It's right?
it just looks the same because they're on black.
I really shouldn't have done black. This was really the problem. We're going to learn a little life lesson. When there's black on black, don't put black on black. That just doesn't work. Yeah.
When you're showing your work with mapping, do you want us to show the substitution, or can you just...
You would want to show substitution if it said algebraically.
Okay.
Yeah. Because if not, if in this case you can't really, you'd have to move it in your head.
Yeah.
But if it was like an equation and then another equation, we wouldn't know if you actually did algebra or if you just went to your calculator.
Okay.
Okay. Example 12, example 13. So, I don't know why I just put the minutes on. Have it. Okay, it's part of my life now. I'm just masking it. Write the equation of the image y equals x squared with a horizontal stretch by a factor of 3/4. So we know x is going to be replaced with 4/3, right? So we're going to go y equals, put it in a bracket if you're replacing it, 4/3 x squared. That one's not too bad, because the original still was just a base function, the parent function of y equals x squared. The next one is y equals square root x minus 3 has a horizontal stretch by a factor of 4, so x is going to be replaced with 1/4 x, both the y-axis, and a vertical stretch by a factor of 2, so y is going to be replaced with 1/2 y. So let's do some replacing and then moving. So we're going to get 1/2 y equals the square root of 1/4 x minus 3. We agree? And now we need to move that half. How do we move the half to the other side? Multiply by every term by 2. Not just the front by 2. Every term by 2. So we're going to multiply this by 2. This by 2. Terms are separated by plus or minus signs, right? And this by 2. So a lot of people will miss the 3 at the back. So y equals 2 square root 1/4 x minus 6. Then C has, after vertical stretch about the x-axis by a factor of 1/3 and nothing. And nothing, that's what it is. So, we know our y is going to be replaced with 3y, because replacement's always the opposite. So I'm going to get 3y equals 3x plus 7. Then how do I get y by itself? Divide by 3. Do all of them. So I get y equals x plus 7/3. Right? So you have to remember to apply it to all of the terms, which is where the error comes in. These ones say, describe how the graph of the second function compares to the graph of the first function. So what's A? Horizontal or vertical? Horizontal stretch. By a factor of 2 about the which axis? Y-axis. Didn't ask for this, but we're going to do mapping anyways. XY is going to become what? 2x comma y. Because we have 2 in words, we're going to have a 2 in mapping, right? Words and mapping numbers are always the same. This one, I have a 3 up here. So this is a horizontal stretch. It's in front of my x. By a factor of what? Three? No, it's 1/3, right? It flips. About the y-axis. And my mapping will use 1/3 because my words use 1/3. Stretches and reflections multiply. Translations add, subtract. C. I have a reflection. Can I state it first? No, I need to state stretches, reflections, translations. No option on that, right? So what's my stretch? I have a vertical stretch. By a factor of 1/2. Is it 1/2? Does it flip? No, it only flips when? Yeah, it's on the left-hand side. This one's already on the right-hand side. So vertical stretch by a factor of 2 about the x-axis. And because it's negative, I don't say -2, right? Because the negative is represented by a reflection in the x-axis. So I'm going to multiply my y by -2, right? Because I used the 2, and reflection means being multiplied by a negative. And it's not with my x, and there's nothing with my x in my absolute values, right? So my x is going to stay the same. This one I have a horizontal stretch. By a factor of does it stay at 2? Horizontal always flips. So by 1/2 about the y-axis. And a reflection in the y-axis. Now my number is 1/2, so I'm going to apply 1/2 to my mapping, right? So xy becomes -1/2 because of the reflection x, comma y. So word numbers become mapping numbers, right? Has it ever changed? Nope. Same rules the whole time. Didn't matter what I added. Words became mapping. Okay, E. So I have a vertical stretch. By a factor of 2 about the x-axis. And a horizontal stretch by a factor of what? Yeah. By a factor of 3, always flips. about the y-axis. And my mapping would be 2 and 3 because that's what's in my words. So xy becomes 3x, comma 2y. Right? Never has changed. Mapping the words, numbers, always the same. For f, I'm going to divide the 3 over. When I divide a 3 over, it's like multiplying by a third. Now, some people will say that's with the x. Is it with the x? No, if it was with the x, it would be 1/3 in brackets cubed, and it's not, correct? So actually, x, if you really wanted to save yourself from trying to say it's horizontal, is you can put a bracket on your. So, it is a vertical stretch. By a factor of 1/3. My brain stopped for a second. About the x-axis. So I get xy becomes x comma 1/3 y. We're not going to worry about these right now because the graphs of those is something we're do different. Don't worry about the assignment for right now. Can you put your masks on because I want to hand out a paper. So remember in this case, the equation we are going to, our base equation is going to be y equals f of x. So we're going to use the whole time, which is a nicer equation, right? Okay. So replacement notation and equation go very well together, right? Mapping and words are basically the same thing, just representing it differently. So for replacement notation, I would go y minus 3 in for my y equals f bracket x plus 3, and then I would subtract my 3 over. So I would get y equals f of x plus 3 plus 3. So that is transformations, right? Or the translations. All of them are transformations. Come on, Lepp, grab a mitt. Okay, see? Need square tires, still rolling. So these are translations. So I have to state stretches first, reflections next, which I have none. So I can go right to my translations. So I have a vertical translation. Three up. And a horizontal translation. 3 left. Then my words and my mapping are the same. So my xy, I'm going to move 3 up. So I'm going to have to go, and 3 left. I'm going to have to go x minus 3 to move that x3 left, and y plus 3 to move that y3 up. And you can visualize moving that, right? The next one I gave you mapping, so if it was my choice, I would do words first, because mapping and words are the same. So, I have two stretches and a reflection, right? So I have to do my stretches first. So I have a vertical stretch by a factor of a third. Because if this is a 2 and this is a third, my words are going to have 2 and a third in them, right? Words and mapping, same numbers. About the x-axis. And I have a horizontal stretch by a factor of 2 about the y-axis. And then I have a reflection in the, with the y, so I have a reflection in the x-axis. This one I'd add my 4 over, so I'm going to get y equals f 1/2 x plus 4. So when I go do my replacement notation, I'm going to replace it for the y, right? Yeah. So I'm going to get x becomes 1/2 x, and y becomes y minus 4, because it's literally what it would be replaced with, right? So if I had to do replacement, actually leaving everything on the left-hand side would be better. It was with the y. Okay, so I have a vertical translation, but I'm not going to state that first because that's just dumb. We don't do that. We do search. We stretch, reflect, translate. So I have a horizontal stretch by a factor of what? From equation to words it flips, so a factor of 2 about the y-axis. And a vertical translation for up. And my mapping and words are the same. So I have a vertical stretch by 2, so I'm going to get 2x. I need to move 4 up, so I have to take my y and I have to add 4 to it. Here I was given words, so I'm going to do mapping right away. Vertical stretch by a factor of a third about the x-axis, reflection in the y-axis, horizontal translation for left. So these two affect the x. This one affects the y, right? So I'm going to have x, y. If it's a reflection in the x-axis, I actually get a negative x. I need to move it 4 left, so I'm going to subtract 4 from it. And then my y, I'm going to multiply by a third. My replacement notation, I'm going to do x gets replaced with, now this is going to be your trick. You need to have a 1 in front of the x in order for the translation to be correct. And this is where I get you guys messed up. Mapping, you literally have no brackets in there, right? It's just negative x minus 4 and 1/3 y. We agree? But when you put it in the equation, you need to have the reflection outside. So it's going to be negative 1, right? Bracket. And now I need to move 4 to the left. So I'm going to have x plus 4. So your stretch and your reflection for replacement notation for x needs to be outside of the bracket. Okay? Sometimes when they have the equation, they'll have it actually inserted. That just means they distribute it after, which is totally fine. Now your y is going to have to be the same. Your y would have to have the stretch and reflection outside as well. The catch is I just have a stretch. So it's going to be 3y. So I'm going to get 3y equals f negative 1 x plus 4. Divide my 3 over, I get 1/3 f negative 1 x plus 4. Okay? For the rest of this, you're going to start copying down what I'm going to put, and it's going to be your homework to fill in the rest. Okay? So, next line, we're going to have x becomes negative 2 bracket x plus 1. Y becomes negative y. The next one, we're going to do mapping. X, y becomes x plus 2, comma, negative 1/2 y. The next one, I'm going to give you an equation. It's going to be y plus 3 equals f 2x plus 2. The next one, we give you words. Vertical stretch by a factor of 2 about the x-axis and then a reflection in the x-axis and a vertical translation up. Then we're going to flip over. There's more. And this one have to go on your homework check for Friday, because tomorrow I'm just going to come and see if you filled it in. Okay? So this doesn't go on your homework check, just page 12, the next page, and then yesterday's podcast review, remember? That one has to go on Friday's homework as well. So this is not. I'm just going to walk around and see, did you fill it in or did you not? Okay, next page. Y minus 2 equals f bracket 3 x minus 1 in brackets. The next one, I'm going to give you x is replaced with 1/2 x. Y is replaced with 3x plus 3. The next one, I'm going to say reflection in the y-axis, vertical translation to up, horizontal translation for right. Next one is mapping. Xy becomes 2x plus 3, comma, negative y. Yep.
In replacement one, do you want it to be 3y plus 3 or 3x plus 3?
Yeah, that's supposed to be a y. Square tires.  3. 3 x plus 3. 3 y 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 plus 3. Remember, I'm rolling. I need square tires. I haven't stopped yet. It's still rolling. Yes, that would be really stupid if it was X. Really dumb. Place the Y with an X, and then just see what happens. Okay. Then we have 3y plus 3 equals f negative x. Then we're going to do x is replaced with x plus 1. Y is replaced with negative y plus 2. The next one, we have a horizontal stretch. By a factor of 1/2 about the y-axis. We have a reflection in the y-axis. And a horizontal translation. Three left. And then our last one, xy becomes 2x plus 3 comma 1/3 y. And then the rest we're going to deal with tomorrow after. So that's your homework, okay?